So here's a video walkthrough of the first problem in the Chapter 8 problem set. It's also the first problem on WebAssign. And this deals with sample means. We're trying to estimate a population mean when we know the population standard deviation, which is doesn't usually happen, but it's the basis of where it all goes. So we've got about, let's see, so they want to estimate how many hours college students get to sleep. So what we're going to do here is get a pen. And they want me to know for part A, they want me to know the point estimate of this. So we don't know what the population mean is. We don't know how many hours on average college students sleep. So what they were going to do is they went out and took a sample, and we said that, let's say they took a sample of 50 college students, and from that sample they found the average, or X bar, was 6.2 hours. So it is less than 7. So does that mean that college students get less sleep than everybody else? Well, on average, this is based on one sample, and as we learned that samples can vary. So at this point in time, the best all we can say is that what's our point estimate? How many hours college students get on average? Well, using the sample, we get 6.2 hours. Now, to get a better estimate, we're going to construct a 95% confidence interval, which will give us a little wiggle room. Say it could be as low as this or as high as this, and that'll help cover 95% of all possible sample sizes. It's still 5% chance we'll miss it, but at least better than just saying this 6.2 hours is the actual mean. So as you learned back when you studied sampling distributions, that these samples can vary, and for a 95% confidence interval, we're going to say that we're going to go to 1.96 standard deviations either side of our estimate. Now, in order to get the standard deviation for the sampling distribution, the central limit theorem tells us, okay, you're going to take the standard deviation for the population and divide it by the square root of the sample size. So we've got a standard deviation for the general population of 1.25 hours. See that right there? And they took a sample of 50 students. So we're going to do that. And then what we're going to do is we're going to do that calculation. So I'm going to grab my calculator and I'm going to take the square root of 50. And I got 7.07. Now, truth be told, I've got more decimal places than that. I'm just going to let my calculator carry that. Then what I'm going to do is I'm going to do 1.25 divided by that whole calculator answer. And I'm getting a standard deviation of, let's see, 0.17. So it's about equal to 0.177 if I round. So now to get the margin of error, and I abbreviate that margin of error, you're going to take the standard deviation, which is 1.77, and we need to go out 1.96 standard deviations to make sure that we cover the middle 95% of all samples. So if I multiply that by 1.96, I'm getting about 0.35. Okay, so that I'm going to take my sample mean plus or minus the 0.35. So it could be as low as the average number of hours of sleep. Well, 6.2. Let me write this down here. It could be 6.2 minus 0.35, which is, let's see, I should be able to do that in my head, but I haven't had enough coffee yet. 0.85 or 5.85. Let me get rid of that extra parenthesis. I don't want to confuse the issue with it. And then we'll do 6.2 plus 0.35, 6.2. Let me fix that. Might as well be clean about it. Plus 0.35 is going to be 6.55. So we're 95% confident that the true mean hours of sleep for college students is between 5.85 hours to as high as 6.55 hours. Okay, now, so that's good. We did B. So does your answer in the previous problem support the claim that students get less than 6.5 hours of sleep? Well, because my interval captures is 6.5 is in between those, the high and the low. So no, we can't say that they get less because it could possibly be 6.5 hours. Is it less than 7? Yes. So that's another thing. I mean, of course, they didn't ask me that there. It is less than 7 hours of sleep. So no, I'm pretty confident that, yeah, college students on average get less than 7 hours of sleep. But the question here, part C, is asking for 6.5. So we can't say that it does. Now, we want to do some sample size calculations. So what I'm going to do is I'm going to clean up this board a little bit. And I'm going to grab a copy of the formula that the textbook gave us. I mean, really, I could show you where it comes from. Maybe I will here once I get this caught. So this is on page 109, and I'm just grabbing that whole formula. We come back and paste it in for us. Okay, let's move that up here. So it's on page 109 if I got it, and we'll just look at that. So where is that? Where are they getting this formula from? Well, if you look up here at the this is the margin of error formula, right? You take how many z-scores or how many standard deviations you need to go, times it by the standard deviation for this sampling distribution, which is the standard deviation with the population divided the square root of the sample size. If I want to solve, now this is algebra, so I hope I don't freak some of you out by that. Now this Z is the critical value based on what your level of confidence is. And there's the 3 common ones that Dr. Stevens pulled out of the table for us. I mean, you can you can find other levels of confidence too. So we're going to solve this for n. So I'm going to divide by z. So that gives me E divided by z equals sigma over the standard deviation over the square root of n. And now this is a proportion, so I'm just going to write the cross products. E times the square root of n equals standard deviation times the z-score. And now, since I'm solving for the sample size, I'm going to divide by E. And that leaves me the square root of n equals, I'm going to rewrite this as z times sigma over E. So the z-score times the standard deviation divided by the margin of error. And now I'm going to square both sides of this equation. That leaves me n, and that's where that formula came from. Okay, now fortunately we don't have to solve that every time. We can just use the formula they gave us. If you don't remember it, you could always solve it. But since this is all open note, why would you want to memorize it? You got other things to worry about. So they want me to come up with a sample size. How big a sample do I have to draw when I'm 90% confident to be within 0.2 hours of the actual mean? So what I have here is my z-score for the z for 90% confidence interval is 1.65, it's 4.5, so you look at that table. And the margin of error is 0.2. And the standard deviation from before, I believe, was 1.25. And all I'm going to do is substitute that into that formula. So 1.645 times the standard deviation divided by the margin of error. And then I'm going to square that answer. Now, maybe it would be good to have you watch me calculate that. Some of you might have a hard time running the running the program. So let me write this down because I'm going to leave the screen. See, 1.645 times 1.25 over 0.2 squared. Okay, so I'm going to try sharing my calculator now. Okay, so what I'm going to do is clear this all out so we can have it. So I'm going to take 1.645 times 1.25. And if you want, you can hit equals right now. This calculator will follow order of operations, so I'm just going to divide by the 0.2. I can do this because I'm multiplying. If I were adding, I would have to, either use parentheses or do that operation first, because we still have to follow the order of operations. So I'm going to divide that, so that's what the inside's equal to, and now I'm going to square that. I'm going to raise it to the second power, and then I have to round up because 105 isn't quite enough. 106 is what we'll have to go with. So to get to be 90% confident and to be within 0.2 hours of the actual mean, I'd have to sample 106 people. Okay. Now let me go back to the board. Share screen. Let's see, where's my whiteboard or my paint app? Here it is. Okay, so that's that problem. Now for the next one, if we want to be within 0.1 hours of the true mean, all we have to change is, let's see, get an eraser. All we have to change is the 0.2 and make it be 0.1, because that's our new margin of error. And I won't show you that on the calculator, but actually I think I've done it once. So 1.645 times 1.25 divided by 0.1, I got that answer, which is 20.56. And then I'm going to square that. I got 422.8. So I would need 423 people to be within 0.1. Notice how much larger the sample size is. The other thing that happens is now we're going to change our level of confidence. So now instead of only a 1.645, we have to go out. So go look at that little shortcut table that Dr. Stevens gave us. For a 99% confidence, we need to, let me get a pen back, we need to go 2.57 or 2.575 standard deviation. So I guess I should have erased that whole thing here. And they didn't change the margin of error on us, so we can leave that. So this becomes 2.575. We have to go out further in order to be more confident, right? Wider interval. So what I'm getting when I do that is 2.575 times 1.25 divided by 0.1, right? Yeah. And then I'm going to square that. I got 1,037 I would need to go with. Okay, so hopefully this helps you get started with this problem and have you make some headway.